Okay, suppose we have a function f of two variables x and y. So we have f of xy. Let's talk about the derivative of this thing. Okay? First thing you need to understand is there's no such thing as just the derivative of this. Okay? Now I know that sounds a little bit earth-shaking, so let me be more specific, okay? What do we mean by the derivative of a function? The derivative of a function tells you the instantaneous rate of change of the function as a ratio of the instantaneous rate of change of the input. And here there's two inputs. So if you're thinking about rate of change, how fast does f change in a ratio with how fast the independent variable changes? Well, f might change quickly as x changes, and it might change slowly as y changes. What if f of x equals, well, what if we just say something simple like 2x plus 5y? Then every time x increases by 1, f is going to increase by 2. But when y increases by 1, f is going to increase by 5. So how fast f increases depends upon what's changing, x or y. And if they're both changing, then are they both changing by the same amount? You see, so the point I'm trying to make is that you really have to break this down and be a little bit more specific and not just talk about the derivative of f. You need to talk about the derivative of f with respect to x, or the derivative of f with respect to y. But x is only part of the input and y is only part of the input, so those two derivatives are called partial derivatives. Okay? And so we use a different symbol. We don't just use a d. We use this kind of a d. Like that. Okay? It's called del. Okay? So I write del f del x. Okay, what is that? Well, for this one time only, I'm going to write the definition of that, but most of the time we'll just calculate it using the derivative rules that we learned in Calc 1. Okay, but what that is that's the limit as h goes to 0 of f of x plus h, comma y, minus f of x, comma y, over h. In other words, y is constant. Okay? So that's called the partial derivative of f, whoops, with respect to y. Okay, and it's very easy to calculate. This is how I'm going to simplify my explanation. Okay, x is treated as the independent variable and y is treated as a constant. That's not spelled right. Okay, so let's do one here. Let's put here 5x squared plus 7y cubed. That's f of xy. Okay, then the partial derivative of f with respect to x is 10x plus 0, so in other words it's just 10x. What if, here, let's make this a little more complicated. What if it's 5x squared y plus 7xy cubed? How about that? Then the partial derivative of f with respect to x would be 10xy plus 7y cubed. Okay, it's very simple as long as you just remember to treat y as a constant, okay? Remember that it's called a partial derivative, not a derivative, and remember that we use a del instead of a d. That's all there is to it, okay? Now you could also do the partial derivative of f with respect to y if you wanted. And technically that's the limit as h goes to 0 of f of x comma y plus h minus f of xy over h. That's called the partial derivative of f with respect, oh, sorry, quick correction. On the one up above, I noticed that I wrote with respect to y, and of course that's not what I meant. I meant with respect to x. Sorry about that. This one down here is with respect to y. So that means y is treated as the independent variable and x is treated as a constant. Now, you can do the second partial derivatives. Those two that I showed you are called first partial derivatives. Would you like to practice this one with the function that I have up above? Let's go ahead and do that. It would be the partial of f with respect to y. It would be 5x squared plus 21xy squared. Do you see that? Okay. Now you can do second partial derivatives. Oh, really quickly, before I forget, because I know you'll see this in books. Another symbol for that, for the first partial derivatives. Let me put them in, what color should I use? I'll just keep it in black, okay? You could just write f sub x. That's another way of writing a partial derivative of f with respect to x. And you might see this. Okay, and for the partial derivative with respect to y, you'll see it sometimes written like this. Okay? Right now, second order partial derivatives. That's the partial derivative of a partial derivative. So there's 4 possibilities. Okay, you might take the partial derivative of f with respect to x and then want to take the partial derivative of that you could do that 2 ways. You could take the partial derivative of that with respect to x, or the partial derivative of that with respect to y. Okay? you could take the partial derivative of f with respect to y and say, I'm going to take the partial derivative of that with respect to x or with respect to y. So there's 4 possible second order partial derivatives. Now, to save time and space, this one up here on the upper left, that's usually going to be written like this. Del squared f del x squared. That's the second partial derivative of f, both times with respect to x. This one in the lower right corner is the second partial derivative of f, both times with respect to y. That would be del squared f del y squared. Okay? Now let's do this one on the lower left. That's the partial derivative. Well, here, let me say it like this. You start with the partial derivative of f with respect to x, sorry. And then you do the partial derivative of that with respect to y. And so it's going to be usually written this way. Del squared f over del y del x. What's very important is for you to remember that that's the one that happens first. That's the one that happens second. Okay, so what would that remaining one be? That's where you take the partial derivative of f with respect to y, and then you do the partial derivative of that with respect to x. So you're going to write it like this. Del squared f del x del y. Okay? This one up here can also be written fxx. This one down here can also be written fyy. This one can be written fyx. Remember, first, then second. Okay? And this one up here can be written fxy. These two here are different things. Okay? By definition, they're not the same thing. Now, sometimes they equal each other and sometimes they don't. Okay? I will tell you the rule for that. Those are called, by the way, mixed partial derivatives. Okay, so here's a rule. Let's write this down. Okay, the second partial derivative of f with respect to x and then y. Oops, I didn't mean to put an equal sign there. Equals the second partial derivative of f with respect to y and then x if both of these mixed second order partial derivatives are continuous. Okay? Okay, let's practice some of this stuff. Okay, let's take this function. F of xy equals y cubed plus 3xy squared plus 3x squared y plus x cubed. Let's find the first and second order partial derivatives of this. I see I left a couple of them off my list. Let me remedy that right now. There's 2 first order partial derivatives, and there's 4 second-order partial derivatives. Okay, so let's find this guy. We pretend that y is a constant and x is the only independent variable. Okay, so the derivative of that would be 0. Here, and that was because y. Why was that last one 0? Because y cubed would be a constant in our case right now. Okay, we're doing this guy, so we're treating y as a constant. Okay, this term, what do we have? 3y squared is a constant, and then that is times x. So when I do the derivative of a constant times x, the derivative with respect to x is just the constant, and so I'm going to get 3y squared. How about this term? I have the constant 3y times x squared, so the derivative will be the constant 3y times 2x, and so that means I'm going to get 6xy. And then this one should be a no-brainer for you. That's going to be 3x squared. Okay, that's the first partial derivative with respect to x. Now let's do the first partial derivative with respect to y. So the derivative of that will be 3y squared here I have y squared times the constant 3x, so I'm going to get the constant 3x times 2y, so we will get 6xy. Here I have the constant 3x squared times y, so the derivative with respect to y is going to be the constant 3x squared. And here I have a constant, so the derivative of that will be 0. It is a 100% coincidence that these two are the same. That'll almost never happen. It's just because of the way our original function was structured. You call that, if you want to know the name, I would say that that is symmetric in x and y, meaning whatever's happening to y, same thing's later happening to x and vice versa. Same thing is happening to both x and y. Okay, that's why the two first order partial derivatives actually came out to be the same. Okay, now let's do this one. What is that? First of all, I want to ask you that. What is that? That is the derivative of this with respect to x. Okay? So here's a constant. The derivative of that will be 0. Here's x times the constant 6y. The derivative will be 6y. And here's 3x squared. The derivative will be what? 6x. Okay, now let's do this one. That is the derivative of this with respect to y. So the derivative of 3y squared will be 6y. Here I have y times the constant 6x, so that derivative with respect to y will be 6x. And here's a constant, and so the derivative will be 0. Again, these two are the same, but that almost never happens. Okay? Now let's do the mixed second order partial derivatives. What's that one? That is the derivative of this with respect to y. So the derivative of that term with respect to y will be 6y. The derivative of that term with respect to y will be 6x. Wrong color. And the derivative of that with respect to y will be 0. Okay, and last one. What's that? That is the derivative of this with respect to x. So the derivative of this term with respect to x is 0. The derivative of this term with respect to x is 6y. And the derivative of this term with respect to x is 6x. There we go. Okay, now, the fact that, the fact that these two are the same is not a coincidence because of what's written up above in purple. If the two mixed order partial derivatives are continuous, then they will equal each other. Okay? The fact that those two are the same as these two is 100% coincidence. I mean, it's not coincidence. I mean, it happened because of the way the function that we started with, okay? But what I'm saying is that almost never happens. But this almost always happens, at least in the functions that you're going to be seeing. Okay, let's erase all of these answers and start with a different function at the beginning. We're going to do 2 more of these practice. All right, let's do f of x equals e to the x plus 2y. Okay, so what's the first order partial derivative with respect to x? Because it's an exponential, it's going to repeat itself. And then we multiply that times the derivative of the exponent. Now we're doing the derivative with respect to x. So what is the derivative of x plus 2y with respect to x? It's just 1. Okay? And so that's our answer. Let's do the derivative with respect to y. Because it's an exponential, it's going to repeat itself. And then we multiply times the derivative of the exponent, which is the derivative of x plus 2y with respect to y. It's going to be 0 plus 2, right? So it's going to be 2. So here's our answer. 2e to the x plus 2y. Okay? Now this one here. You look at this and do the derivative with respect to x. So that's going to be e to the x plus 2y times 1. Now let's do this one. You look at this and do the derivative with respect to y. So that's going to be 2e to the x plus 2y times 2. So we get 4e to the x plus 2y. Okay, and now the 2 mixed ones. For this one, we look at this and we do the derivative with respect to y. So that's going to be e to the x plus 2y times the derivative of x plus 2y with respect to y, which is 2. And finally, the last one, we look at this and do the derivative with respect to x. So we're going to get 2 e to the x plus 2y times 1. And there's our answers. Okay, and let me pick one more. Okay, I'm going to make one that's not hard, but has things like the product rule that you have to worry about, okay, and some trig. So let's do this. Let's do cosine of x squared y times sine of 2x plus y to the fourth. Okay, how about that? Okay, so derivative with respect to x, the partial derivative with respect to x. Okay, so I need to use the product rule first of all, because there's a product and both of them have x's in it, the cosine and the sine balls. So what do? I do the derivative of the cosine part times the sine part. Derivative of the first times the second. And when I say derivative in this case, I mean with respect to x. So y is a constant. So this is going to be, it's not hard at all, but there's going to be a lot of pieces to write down. So what's it going to be? It's going to be negative sine of x squared y times 2xy. That's the derivative of the first. And then that needs to be multiplied times the second. Okay, and then we have plus the first times the derivative of the second, which is going to be cosine of 2x plus y to the fourth times what? Times 2. Okay, now let's do the partial derivative with respect to y. Okay, it's going to be derivative of the first, so that's going to be negative sine of x squared y times the derivative of x squared y, which is going to be x squared, times the second function plus the first function times the derivative of the second, which will be cosine 2x plus y to the fourth times the derivative of 2x plus y to the fourth, which is 4y cubed. Okay? We won't do the second order ones because there's just going to be massive answers. Not at all difficult, but just going to be a lot of writing because there's two terms, but look, each term is a product of three things. So you're going to have to use the product rule inside of the product rule, and it's not hard, but it's just very time consuming. So let's not worry about this. Okay, let's move on. So there's something called the total differential of f. Okay, so again, we have f of xy. Okay, the total differential, not derivative, differential of f. That means df Okay? What is it? It is the partial derivative of f with respect to x dx plus the partial derivative of f with respect to y dy. So tell me, what is the total differential of f of xy equals x sine of y plus x squared? Let's find the total differential of that. So let's just do some scratch work first. What's the partial derivative of f with respect to x? That's not difficult, is it? That's sine of y times 2x, plus 2x. And what's the partial derivative of f with respect to y? What would that be? Think about it. Isn't that going to be x cosine y? So here's the total differential of f. It's sine of y plus 2x dx plus x cosine y dy. Okay? Pretty straightforward. We're not doing anything totally new here as much as just learning some new terminology, really. These are just derivatives is all they are. It's just a question of, are you doing a derivative with respect to x or y? Okay, and then the last thing I want to talk about are, how does the chain rule look like in this case where you have functions of several variables? Okay, so chain rule, there's going to be two of them because it depends on something. When does the chain rule come into play? It comes into play when you have a function plugged into a function, right? A composition of functions, right? Okay. So one possibility is if you have f is a function of two variables, x and y, and those are each functions of one variable. Okay, this is the first type. Okay, f is a function of two variables so right, f of xy. Okay, and then x and y are each functions of one variable, not just one each, but the same one. So right, x equals g of t and y equals h of t. Okay? So then in that case, f of xy is technically a function of t. It'll be f of g of t comma h of t. Okay? Do you see how it would be a function of t? Let's do an example. Let's just suppose that x of t is t plus 2, y of t is the square root of t, and f of xy equals sine of x squared y. Okay, then what is that then? That's equal to the sine of t plus 2 squared times the square root of t. Do you see how that's a function of t? So if you were going to do the derivative of that with respect to t, then I have a question for you. Would that be a partial derivative or a regular Calc 1 derivative? Well, there's only one independent variable, which is t. So if you wanted the derivative of f with respect to t, that would just be a normal Calc 1 derivative. In other words, it would be df dt and not del x del t. Okay, but it's not obvious, though, how to calculate it. I need to show you that. Okay, so we would write df dt, because this is a normal derivative, because there's only one independent variable. Okay, but how would you calculate that derivative? So here's what it is. I am literally going to rewrite this and just ask you to remember that the numerator is this. Okay, so I'm just going to write del f del x times dx plus del f del y times dy over dt. And if I simplify that, how's it going to look? It's going to look like this. Well, first of all, I could write this but better is to write this. So there's your answer. df dt is the partial derivative of f with respect to x times the derivative of x with respect to t, plus the partial derivative of f with respect to y times the derivative of y with respect to t. Okay? Now what's the other possibility? That first possibility is where you have functions of one variable plugged into a function of two variables. The other possibility is to have functions of two variables plugged into another function of two variables. Oh, I forgot to put the word 2 up there. I just wrote f as a function of variables. Of course, you know what I said was two variables. Okay, so now in this other possibility is f is a function of two variables so we have f of xy. Okay, x and y are each functions of two variables. So we'll write x equals g of st and y equals h of st. So now, if you wanted to do the derivative with respect to f, so first of all, f of xy would be a function of two variables, wouldn't it? Because you would have f of g of st comma h of st. So you would have two independent variables, s and t. So if you wanted to find the derivative of f, you can't say the derivative of f like we did here, because there was only one independent variable. Now there's two independent variables, so you have to say, if you're going to differentiate f, you have to say partial derivative. And there is such thing as a partial derivative of f with respect to s, and there is such thing as a partial derivative of f with respect to t. Okay, and they are, respectively, the first one would be the partial derivative of f with respect to s. Sorry, I meant to say x. Times the partial derivative of x with respect to s plus the partial derivative of f with respect to y times the partial derivative of y with respect to s. And the partial derivative of f with respect to t is the partial derivative of f with respect to x times the partial derivative of x with respect to t plus the partial derivative of f with respect to y times the partial derivative of y with respect to t. And the computations are very, very easy. If you passed Calc 1, then they are easy. Okay? All right, that's it for today.